Hello, everybody. So, hopefully everything runs smoothly here. I have sort of all slideshow, some sort of live online demo, so I'm hoping that's going to work well. The title of my presentation today is Enhancing the Authenticity of Assessment, and hoping that this presentation, amongst inspiring people to create great content, might inspire people to create better content and hopefully share that content, as we've had some discussions on already. So to tell you a little bit about NAIT, NAIT is formerly known as the, or formally known, not formally, formally known as the Northern Alberta Institute of Technology, and we are in Edmonton, Alberta, Canada. Essentially, NAIT is broken up into a whole bunch of different facets: business, culinary arts, skilled trades, con ed, health and life sciences, corporate international training, and applied sciences and engineering technologies. I taught at NAIT under the flagship applied sciences engineering technologies in the area of mathematics for 6 years. Essentially, NAIT is probably best known as a school that's really in the heart of oil sands country in Western Canada. So we are home to Canada's largest apprenticeship training program. So everything from culinary arts that maybe cater to some work camps and just general industry in Alberta, to alternative energy programs, to petroleum energy programs, to electricians, to pipe trades, to a little bit of everything. We're known as a polytechnic, and we are quite large, catering to roughly 20,000 students a year. And I just looked up a minute ago that we actually do 1.2 million course registrations on an annual basis. So we're quite large in the sense of establishing a footprint in polytechnic education. With being a large institution, we have a number of challenges, and I'm going to present those challenges to you, and then present why our institution adopted Maple TA as a solution to these challenges. And the first challenge is to develop leading-edge courseware that is directly tied to industry. So to preface this, I will point out just about 3 or 4 years ago now, I was instructing a group of power engineers. And these power engineers were working on some homework that we had from a common publisher. And they were working on some homework questions. And the homework question that they were asked, there we go, was a coil spring in a car that oscillates according to some sinusoidal function. And these power engineers, like many other students, asked the probably most notorious question: when am I ever going to use this? And as an instructor, I looked at the question and looked at it and thought, well, you're not. You're not at all. You're not going to deal with coil spring oscillations as a group of power engineers. And that's a real challenge for us as a polytechnic, who's supposed to be training students to become very industry-driven, industry-ready education. What would be convenient for us is to be able to actually sort of retool that question with a great bit of ease and ask them maybe something to do with a sinusoidal function, but something more applied to their particular field of electronics or electrical components. So that's one of our challenges is across our institute, is to develop this really rich content that is directly tied to industry. And to do so, we can spend countless hours researching publication products or open source products to be able to do that. Or on the other side to it, maybe we can develop something from scratch, or we can find ways to retool our content. And that leads us to our solution. The first solution is to use authoring tools that allow instructors to sort, create, and modify their content with a great bit of ease. And many of you, I'm sure, are familiar with Maple TA, but perhaps for anybody that is not, what's really convenient with it is the ability for us to be able to sort of retool our content. So I'm going to lead you through this as part of a demo. Hopefully I can get my one of many passwords correct. another thing as I'm going through this, I should point out what I really like is the LTI connection between our campus's LMS, which happens to be Moodle. Oh, ha ha ha. Great. Now it'll come back. Sure, just duplicate them back. Thanks. Perfect. Now that you're not looking at a blank screen. Thank you. So one thing I really like is the integration with our campus LMS, which happens to be Moodle. So what I did do here is I loaded up a Moodle course, and within there I have a link to MapleTA, whereby I can create all my assignments. But for the purpose of retooling questions, in my content repository questions, I have this coil spring oscillation question. And what I find really awesome with MapleTA is the ability to sort of retool your questions with a great bit of ease in a short bit of time. So even though this question was initially authored perhaps for a mechanical engineering course or some other, I'm able to actually go into the question and retool the bits and pieces that I need to. So I might say, voltage in AC, in an AC circuit, etc. And I can retool this question very quickly. I can change the equation to the question, and I can change the answer to the question just with a few mouse clicks. So it's super convenient, easy for us to do that. And the other thing that I really like is the ability, and I notice that this is really growing with the platform, is the ability to start to search and find things with a little bit greater ease. So for example, like the image here, I can browse the server to look at prior images that we've loaded into the course and actually search through those images. So if I just type in AC, I can find maybe a picture that's more relevant to this particular example. So the ability to customize our content, I think, is really robust in MapleTA and allows us to really deliver courseware that's now customized for our group of students that we have in front of us. And we don't have to spend a great deal of time building 200 questions for mechanical engineers and then rebuilding or researching new questions to find for a group of power engineers. So the ability to switch back and forth very quickly is awesome for us in MapleTA. Here we go. Let's see if I can. Here we go. Perfect. So our inherent challenge number 2 is to enhance courseware by means of scholarly activity, research, and sharing. So one thing that we run into is, to preface this, we have a group, again, maybe this time it's electricians who are working in the trades, that are trying to develop a safety course. And within that safety course, they have a whole bunch of different outcomes and topics that they need to present on. So for example, the use of industry tools through to personal protective equipment. And all of these different outcomes and all these different types of courseware that they have to build might happen, some of this content, as you're going to see, might happen to be shared by a group across either in the campus, a group of welders. So for example, certain bits and pieces of witness training or certain pieces of personal protective equipment or PPE might be used by both groups. So we're going to develop courseware that's being delivered to electricians that we can synonymously use with a group of welders. And maybe it's possible some things directly overlap, and maybe it's possible some things don't overlap at all. So we have this nice, that's one of our challenges is to find a piece of software, if we can, that can sustain this and take things that are proprietary to one trade, build it, but things that are maybe shared between 2 different areas and edit it as need be. And that presents us to the solution to that is to use authoring tools that do allow the seamless sharing of content. And right now, in our LMS environment, that's not possible. In a lot of other environments, that's not possible. But in MapleTA, we certainly do have the ability to do that. And this is sort of what we're going with this, is be able to take content that's developed in one building on our campus map and really share that content across all of our other areas in our campus. And we can choose to either institutionally share content so we can browse all of our own stuff, or we can choose to maybe share content just amongst our classes, right? So that presents that nice sort of solution to the challenge of courseware that's not necessarily proprietary, that does need customization. So we don't have to start from scratch with brand new courses and brand new programs that want to get online. And I mean, I hope anyway, that with a platform that really doesn't care what LMS you are using, I'm hoping that we're going to be able to, as a single partner in this, start to build content and grow content, that we start to see this happening. And we start to see the exchange of content across the globe. Because ultimately, that's going to create the efficiencies that I think really are needed right now. Our students, especially at our college, I think are getting tired of paying $250 and $300 and $400 and $500 for textbooks and other things. And when we got tools like this that can edit content so easily, you can take mechanical engineering content and turn it into power engineering content in a matter of seconds. As you can start to share and start to edit things, we can really create some efficiencies that way. But the third challenge, and perhaps one of the most eye-opening challenges, is other constraints to online authoring. And I think it's no secret that a lot of instructors put their heart into their lessons, right? And they try to deliver lessons that are rich, that are engaging, that are dynamic, that are keeping their students' attention. But the assessment side, I know it's very different. The assessment side has stayed, for the most part, very black and white. And never once was I teaching where I handed out a worksheet to the students and they said, my God, this is the best worksheet ever. Right? That never happened, right? I have had it happen where after delivering a lesson or a series of lessons, you stand in ovation. I've had that privilege happen very often, but students are engaged, they're totally excited. You're the best math teacher ever. I'm super excited to be in class today, but I've never had them say, I'm super excited to do this worksheet and hand it in tomorrow. Right? It's never happened. And with online content, someone brought this up in an earlier session, it's an opportunity. It's a great opportunity to take content, move it online. And some of us have been doing that. Some of us have been doing that with, my God, that's an Apple IIe, right? Or an Apple II, right? And we've been building it online, but we build it online with like multiple choice, and fill in the blank, numerical response. And it's really still not that engaging. And students are still not really going, I'd rather do that than go home and play Call of Duty, right? So how do we bridge that gap? That's our challenge, is how can we make something that's really engaging? And so the solution for us is MapleTA. We can use a tool that does present limitless possibilities. And to show you what I mean, we're going to go back over to here and lead you through a few things. So one thing that I really like about MapleTA, first of all, before we really get into some dynamic stuff, is the nitty-gritty of it. So the smartness, right? I don't want to have to release an assignment to students, have students submit it, get 50%, and after I go in and adjust the grades, they actually got 85. It's really disheartening to the students, and it's really workload for me. So smartness in the grading is awesome for MapleTA. So 6 inches plus 6 inches, I'm going to expect the students are going to answer with 12 inches. But what's really neat about it is the students that decide to even go to like 30.48 centimeters, right? And that's no problem. They get it right? And what's really kind of cool about it is also 0.3048 meters. And that's okay, no problem. Oh, 3048. Well, at least you know it doesn't mark everything, right? So 3048 meters. And you know, in Canada it's really common that we get students to spell meter like that, and it's also really common that we get students to spell meter like this, right? And you know what, at the end of the day, it's time saved, because when I built this question, it took like 3.2 seconds. I punched in one answer, I punched in 12 IN, that's what I expect the students to write. It's going to grade everything. Not everything right, but it's going to grade everything that's equivalent to those 12 inches, that's the answer. Another one from the algebraic sense that I think is just absolutely marveling is the derivative of this. So the student punches in 2x plus 6, and you notice I missed the star, right? I missed the little asterisk between the 2 and the x, but it's okay, the student gets it right. Okay?
And I'm going to expect that some students, I get students to do this all the time, they try to trick the system, right? Try to create work for my instructor. And they go, okay, I'm going to go 6 plus 2x, okay? Try to break backwards. That's okay also. But I get students who are really thinking and the wheels are turning and they're really trying to make my life miserable and they decide I'm going to factor out the 2. Okay? And they're going to factor out the 2. That's okay, no problem. Okay? And by now, a lot of students are thinking, it's grading everything right. Okay, well, we'll just make sure that it's not going to grade everything right. It does, in fact, work. Okay. So smart grading, essential, absolutely essential. Down here for part C, what I really find neat is it says list the colors of a typical traffic signaling device. So red, green, and yellow. Well, to me, I could put 3 boxes, right? But if I put 3 boxes, I don't know what order the student's going to put red, green, yellow. So in most platforms, I have to build 3 boxes, and I have to say red, green, or yellow, red, green, or yellow, red, green, or yellow. Okay? I myself, if I'm in that class, I'm going to write yellow, yellow, yellow. I'm going to get 3 to 3. Okay? I myself am going to do that. But there's problems with that. 3 boxes is an indication there are 3 answers. Okay? 3 boxes, when you're saying find the zeros of a polynomial, means there's probably 3 zeros to the polynomial. Okay? It's very suggestive. What's neat about Maple TA is to be able to use something where it really doesn't matter, where we go red, green, and yellow. We go, how did I do? And we get it right. And then the other student, instead of going red, green, yellow, goes yellow with caps, green in all caps, okay, and red in lowercase. And is going, I'm really going to make sure my teacher's working today. Okay, they're grading this whether they want to grade this or not. Okay, and I'm going to go, how did I do? That's no problem. You get it right. It's perfect. It's smart grading, essential. It's a good starting ground, and Maple TA does that for us. But you're really seeing fill in the blank. You're seeing 1998 at its finest with a great calculation engine. So we're going to grow on that a little bit more, and we'll look at something like this, where you can create an image that has randomized text on top of the image. So, you got this text in here is actually, it randomizes, so every student will see a completely different calculator. Every student's going to see very different numbers. And it's really just asking students about their interaction with the calculator, making sure they know how to round, make sure they know what sig digs are, and things like that. So it's smart in the sense that I don't have to build like 15 different images of my calculator, and take my calculator and take a picture, take a picture. You get to take one picture of the calculator and overlay the text on top. It's genius. Maple TA can definitely do that for us, and is. We'll keep going. This was actually built using the Maple engine. What's really neat about it is it's an image on top of an image. Okay, so I took literally a blank multimeter, put it up there, and then I used Maple to actually draw the actual arm of the multimeter and put that image on top of the image. Okay, so it's completely random, so every student will see a very different placement of the needle. I don't have to draw in position A, position B, and C. It's going to be very random every time the question loads. The multimeter is going to show in a different position. So we can do that. We can really grow on this and use the power of Maple to generate some of these visualizations. And the next one, did the same thing. Okay? Just built a multimeter in the background, a single image static multimeter, and used Maple's animate plot function to animate a plot on top of the multimeter. And what's awesome about it is it's randomized. So right now it says 515 hertz, but student B is going to see something totally different. And I can control that as it passes back and forth. Essentially, I have unlimited questions that I can ask that are super, now starting to get very visual and interactive for our students. Okay? Still not quite Call of Duty-ish, but we'll get there. We'll get there today, not in 5 years. Okay? This guy just drag and drop, nice and simple. Not so nice and simple. Okay, there we go. Figure out the keyboard. Drag and drop, we created a question where students are drag and dropping answers, and what you're seeing here actually is something not mathematics, right? But what's awesome about it is the math that goes sort of behind this. They can help build these type of questions. And we're seeing that across our campus right now. I've got culinary arts that's using Maple TA. Okay? Johnny Zipku and I were just before the session, we were just discussing that NAIT has some content on the cloud with sex ed. We have sexual education. This is twice now. Sex has come up in this conference. This is strange. I don't know what's going on there. But yeah, NAIT actually did share some sexual education content on the Maple Cloud. You're going, why are people building that? Okay? Awkward enough, I was doing a demo like this, and I was showing people how easy it was to search the cloud, and I was addressing the audience, and I just clicked on something randomly, and boom, there was this massive image behind me, and everybody just erupted and laughed. Oops, that was me. We did share some content regarding the male anatomy on the Maple Cloud. Enjoy searching for it. But in any case, more relevant things to the discussion of authenticity and making things better for your students. What's awesome about this is how easy it is for the student to react to this and really just plot something. So I really enjoy this. The student's interaction is very easy. I've seen other platforms where they're flash-based, so they don't work on mobile devices, and they will completely not work in 2020. Okay? This is all HTML-based. It's all live. It's all device agnostic, so it's going to work really nicely on a mobile device. It's fantastic. Much better than multiple choice, having to select from a drop-down. Same thing here with the free body diagram. The student can draw a free body diagram with a great bit of ease inside Maple TA. And if you're new to the platform, you're looking at something like this and going, wow, this guy must have spent hours building that. No, it literally takes like 60 seconds. In Maple TA, it's a pre-built asset. You simply click on it and say, hey, it's a free body diagram tool. You load your image in, you draw your 4 arrows, and you're done. Okay? You can build free body diagram tools and plot tools in really a matter of maybe a few minutes. Maybe that's, I would say, for most, it's under a couple. This was built, actually, this is something from the Maple Cloud that I built, and what it is I didn't build this, but somebody built a math app that deals with resistors. So what I did was hit part of the worksheet that would basically tell the students the answer. We randomized the contents, so a student here has to build a resistor that's 37 million ohms. And what's cool is when they change this color to red, it changes the first band to red. We'll change that band to red. And you're starting to find out right away that the guy at the front of the room has absolutely no concept of resistors. You're absolutely right, okay? Zero concept of resistors. But that's the idea here is how cool it is and how nice it is to be able to build some content like this. And next one. We've got, this text here is randomizing, so some students are asked about middle finger, some will be asked the thumb, some will be asked ring finger, etc. And of course the bone itself is also randomized, so it completely randomizes the text inside the image, and then the student actually has to click on the various bones on the hand to resemble that. Okay? So you're starting to see something that is way outside the realm of analytical sciences and more in the realm of biological sciences, and how nice and quick and easy it is for our staff to build these questions in a what you see, what you get environment is probably the principal reason why we have such a wide adoption to Maple TA. It's really quick. It's awesome to build stuff. Labeled the image with answers on top of the image, which is pretty neat. So students can actually respond to the question natively right on top of the image rather than having to scroll down and then reference like A, B, and C. Look at a couple more. We built this, this is a new one. Actually, I don't think anybody from Microsoft's seen this yet. It's really kind of new. We built this as a diagnostic imaging tool so the students can interact with like an MRI or CT machine, and they can see the various layers of tissue in the X-ray. And what's kind of neat about it is the students can then measure between the bones. And they can see there's 13 millimeters, and then they can use the great, awesome, powerful analytical feature within Maple TA and that analytical drive to be able to smart grade the answers. So we can have some flexibility in the students' answers, and we can do that. Okay. So it's pretty neat that we can now actually start to simulate an actual MRI or CT machine in a virtual environment. And at the comfort of the student's living room. So maybe now they're not playing Call of Duty as much, right? This was pretty cool. This guy here lets you drag and drop onto the actual orbit, so you can see how things move and what have you. I did not build this. I give the credit to the Microsoft team, the geniuses there that built this content. It's fantastic. It's probably the one that really grabbed my attention first and was like, if they can build that, I have to see how this thing works. And it's fantastic. It's really cool. There's grading code attached to this, so as the student gets the question partially correct with Earth only in the third position, it partially grades the student correct. Look at a couple more. We got this one for dental. So a student here can manipulate a 360-degree dental x-ray to be able to determine the alignment of the teeth at the front of the mouth, as well as align the teeth at the back of the mouth. And a student can even zoom right in if they want to on the image to determine various things about the teeth. So we did build that. What's nice about it is after the student's done with the teeth, they can then determine the type of classification that the teeth are. So completely non-analytical using Maple TA. This guy, I don't know how much time do I have left, but I got about 3 more examples.
Yeah, that's fine.
Okay. This guy asked students, again randomly, 16-volt battery source, so every student will see a completely different battery source. These students are asked to build a parallel circuit, and they're asked to contain one branch with 2 18-ohm light bulbs and one with a 17-ohm light bulb. So students are going to see completely different numbers at the top. They'll have to build completely different circuits. And the students then can open up the tool, and they can drag and drop the battery in. And basically, as they interact with this, you click on the battery, you can then change the voltage from 9 volts to this 18 volts. I think it said 16 volts. Okay? But in any case, you get the sense the student here can then drag and drop the components of the circuit in. You might be wondering, well, how's this going to be graded, right? How can I be sure that my student did build the correct circuit as indicated? Well, what's really neat about it is, we'll just complete the circuit here with some components anyway. In fact, let's build a, there we go. Come on now, laptop, there we go. So the student completes the circuit, light bulb turned on, which is obviously a good thing. And the student then will go down here, and the student is going to drop another light bulb here, and that light bulb turns on. So we got our parallel circuit. We're happy with that. And the student then can take the voltmeter and then drag the voltmeter out onto the circuit to determine the voltage drop across the given light bulb, and then of course answer the questions with Maple TA. Because if they get the questions wrong, that either means what? They couldn't use the automated voltmeter, which is highly unlikely, or they built the wrong circuit. So we can do that. We can build something that's now much more interactive for your students. So potentially now, instead of, they've got 2 hours in the lab, and after those 2 hours are done, they can't get back in that lab again. So how's the student going to be able to practice? Well, they can practice at home instead of playing Call of Duty. We can do that. We keep going back to Call of Duty. You now are finding out why my Xbox is unplugged at home. And the next one, hopefully it loads. This is really neat. This is an interactive phoropter, so for ophthalmology. So we do have an ophthalmology, we have actually I think 3 different ophthalmology areas at the Polytechnic at NAIT. So what a student can do here is hit begin test, and basically now the student can perform a simulated eye exam on the patient. So what you're noticing here is I close the patient's eye, and this font on the right has become blurry. And as I adjust the phoropter, the font becomes now crystal clear. Okay? And of course, if I was to close both eyes, this patient wouldn't be able to see anything. And then if I open that eye, the font is a little bit blurry, and now it's very blurry. Now the font is getting very clear, and the font is getting way worse. So what we can do is we can actually simulate an interaction with the patient and then basically determine the prescription of their lenses. And there's one last example that we're just working on now, and I hope it's open over here, and it's not. So we're going to let it load here. But maybe while it's loading, I'll jump back over to my PowerPoint. And yeah, so that's our solution, is to use a tool like Maple TA to allow us to build really robust content that's really engaging for our students. And questions? Well, I think while that's loading, I will answer a few questions. Yes.
More just clarification points. So the last few examples that you showed, those aren't tools that are within Maple TA or Mobius. They're more
Correct.
Embedded content and then kind of referencing questions based on that.
Yeah. So to be very clear, like the free body diagram tool, definitely, that's something that's there in Maple TA. The graphy tool, that's something that's there in Maple TA. The planetary movement question, the phoropter and things like that, Maple TA does allow you the ability to actually write your own HTML5 and inject it directly into the questions. You can also inject Flash, although I don't think they would recommend that anymore. But it's the features there. So yes, this is content that basically you can find another applet and then inject that applet as part of your actual assessment. Correct. Yes.
It's been going on for enough time for you to evaluate the whole endpoint.
So the question was regarding basically how much time we've used Maple TA and whether, I guess, what kind of impact maybe that has had on our institution. Essentially, we started using Maple TA just August of just this past August. So we haven't been in Maple TA very long. My role as a teacher of mathematics has been transitioned. I now work in sort of an institutional and faculty support role to help them get coursework online. And through that, we're encouraging faculty to develop more coursework online, and they can come to me and I can work with them to get into Maple TA to do so. The impact that has had, definitely we're seeing really positive effects on workload, staff workload. We've had multiple people who teach labs. So for example, they draw blood from patients, test the blood. They have like worksheets that they literally, I saw it, they had like transparencies that they put over top of the student's page and then they would mark it that way. Because there was like, there's a tolerance between all these numbers, like cholesterol levels, things like that. And there's all these tolerances. So they would have to say, like, they'd overlay this, and it would take them hours and hours to grade these student labs. And now with an analytical engine behind it, we can have those auto-graded for them. So it's had an immediate effect on staff workload with regards to grading, absolutely. Oh, yeah, this is our house, our digital house, which is really kind of cool. So what this allows you to do is actually walk into the house, and the student can then walk into the house, and I'm just going to walk a little bit further, there we go. And this allows us, why this is so neat for us is, trying to figure out where in the house I'm standing. Here we go. You can change to the rough-in stage, and we can put electrical and HVAC in. And we go installation stage, drywall stage. And so you can actually go in, and if I walked over to the outlet, you can actually see the outlet in the wall, and you can actually there's a measurement tool down here, so you can measure the space between outlets. If we go to like full finish stage, oop, come on now. Go back to there, there we go. So there's our outlet in the wall. And the student can actually walk through this whole house. This house is actually, this project was, we went with a home builder that was building a house, and as they built it, we went into the various stages of installation, measured absolutely everything inside the house, so that we can build an assessment tool from it for HVAC, for plumbing, for all the trades. And that was important to us because our winters, we do see minus 40 degrees regularly in the wintertime, and it's not practical to rip out all the insulation and all the drywall to let people see behind the walls on a regular basis. So we were able to build this virtual house. And of course, after a student has done an interaction with the virtual house, they can be asked questions like, does the kitchen island have a sufficient number of receptacles installed? And what part of the Canadian Electrical Code does the installation represent? So we're able to build a whole ton of questions around this house. Basically, I'd say hundreds of thousands of questions around one digital object.
Great.
Any other questions? Or do we have time for another one?
One more question, if there's one.
Yes.
Does these questions lie in the skies?
It's a very good question. The house right now does not. The phoropter right now does not. Some of them do, and some of them do not. We have different views at our institute right now, being respectful of all of those views, different views with regards to sharing the content on the cloud. The content that I create,
iShare, but unless it's created for another program. That's a challenge. So the answer to your question really is, some of them do, some of them do not.
Great. So if people do have more questions, they can obviously talk to you now. We have about 20 minutes before the shuttles come, and then of course, though, I believe Mark is coming tonight, the reception. Feel free to grab him and learn more about how to do this stuff at NAIT.
Thank you.